Interconverting amount of radioactive decay and half-life. So for these kind of questions, we are going to take advantage of the fact that radioactive decay follows first order kinetics. So the half-life, T1 half, is equal to the natural log of 2 divided by the rate constant K. The natural log of 2, if you don't want to put into your calculator, is about 0.693. So we can then rearrange and solve for K. So K is going to be natural log of 2 divided by the half-life. And in fact, we can just go ahead and calculate that for our iodine 125. So natural log of 2 is going to be about 0.693. And the half-life in this case is 60.25 days. So my value of my rate constant is going to be in inverse days, if you like. We'll just stick to that for now. So that is going to be about 0.01150 inverse days, so days to the -1, if you like. Okay, so then we are going to take our activity. So ln of the number time t divided by time 0 is equal to minus k times t. So if we know what k is, because we just worked out, we know how much time has elapsed, we can relate that to how much we have remaining. Now, we were asked for a percent, how much percent was left after 16.1 days. If we were asked for an actual amount, we would need to know n0, like how much there was to begin with. So to make it a bit easier, I'm going to do e to the power of both sides to get rid of that natural log. So I end up with the ratio nt to n0, which is just going to give me my percent, right? And then on the right-hand side, it's going to be e to the power of minus kt, and we've just worked out k. So we have everything we need now to calculate that. So I'm going to do e to the power of minus 0.01150 inverse days, days to the -1, times the amount of days that passed, 16.1 days. So that's going to cancel out unit-wise, give me something that is unitless. That comes out to be 0.83 blah, 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 which is a decimalized percent. So we can just say that is 83% will be remaining. And that is all you need to do for that kind of question. All right. Hopefully that's helpful for you guys.